Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your younger brothers and sisters, and to your friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies as part of your preparations to engineering life, then please don't forget to subscribe. Level 116, determine the product of inertia of the area with respect to the x and y axis. So here is the given figure for our solution. Let's select vertical strip, and the height of the strip is y. The distance of the strip from the y-axis is x. The thickness is differential x. And the centroid of the element is here. So therefore, in the formula Ixy equals integral of xy differential area, x is just x, but y is y over 2 because it is the y coordinate of the centroid of the element. And differential area is area of this strip, which is y times dx. Limits would be from 0 to 2. So Ixy equals integral from 0 to 2 of xy dA. So it is equal to integral from 0 to 2 of x, y is y over 2, dA is y dx. So Ixy equals 1/2 integral of x times y square dx from 0 to 2. So y is given, it is quantity x cubed plus 2x squared plus 4x all over 8. So Ixy equals 1/2 integral 0 to 2 of x times quantity x cubed plus 2x squared plus 4x over 8 square, quantity square over 8 square dx. Now, you can evaluate this because the calculator is allowed for those who are reviewing, but for those who are taking up statics and are still students, then you have to evaluate this manually. But if this is a problem in integral calculus, but if it is a problem in statics, I think your professor or your instructor will allow you to use your high-tech calculator because it is allowed in the board exam. But I just assume that it is a subject in integral calculus that you're not allowed to use your high-tech calculator yet. So let us expand this. So 1/2, 1 over 128 integral from 0 to 2 of x. Then we write this as x times quantity x squared plus 2x plus 4 quantity square dx. So this is now Ixy equals 1 over 28 integral 0 to 2 of x cubed times the square of the first is x to the fourth, square of the second 4x squared, square of the third 16, twice the product of the first two, 4x cubed, twice the product of the first and the last, 8x squared, then twice the product of 2x and 4 is 16x, which is this. Then simplifying, combining like terms, Ixy equals 1 over 128 integral 0 to 2 of x cubed quantity x to the fourth plus 4x cubed plus 12x squared plus 16x plus 16 dx. So Ixy equals 1 over 128 integral from 0 to 2 of x to the 7 plus 4x to the 6 plus 12x to the 5th plus 16x to the 4th plus 16x cubed quantity dx. Then integrating by the power formula, Ixy equals 1 over 128 quantity x to the 8 over 8 plus 4x to the 7 over 7 plus 2x to the 6 plus 16x to the 5 over 5 plus 4x to the 4th from 0 to 2. So Ixy equals 1 over 128 quantity 2 to the 8 over 8 plus 4 times 2 to the 7 over 7 plus 2 times 2 to the 6 plus 16 2 to the 5th over 5 plus 4 times 2 to the fourth minus lower limits 0. So using now your calculator to evaluate these terms inside the brackets, then divided by 128, Ixy is equal to 437 over 140 inches to the fourth, or approximately 3.121 inches to the fourth, to four significant figures. So that's it for this problem. Level 117, determine the product of inertia about the xy axis of the circular area with three equal square holes. So here is the given figure and the problem for our solution. Since this is also the centroidal axis of the circle, the moment of inertia of the circle with respect to xy axis is 0, and the reason x and y are the axis of symmetry. Then we have to subtract the moment of inertia, product of inertia of these three identical squares with respect to this axis. But these lower two are symmetrically placed from the y-axis, therefore their contribution would be will vanish. It will just be 0. So that leads to just subtracting the transfer formula for product of inertia of this square with respect to this axis. So Ixy is equal to, for the circle, it is 0. Then we have to subtract only this one. So by transfer formula, the centroidal product of inertia of the square with respect to its centroid is 0. So minus quantity 0, then plus area, which is 3 times 3, 3 square. Then barred x is negative 3.5, barred y is positive 3.5. So minus 0 plus area 3 square, barred x negative 3.5, barred y positive 3.5. So therefore Ixy is positive. It is positive 110.25 inches to the fourth. So that's it for this problem. Level 118, determine the product of inertia about the xy axis of the area bounded by the half parabolic complement and the lines shown. Also determine the product of inertia of the same area with respect to the centroidal axis. So here is the given figure, and to solve this problem, for our solution, let's consider vertical strip in our solution. Then the thickness of the strip is dx, and the height is y as shown. The centroid is here. So the distance of the strip from the y-axis is just x, and the centroid is, of course, half of the rectangle. So therefore, the y-coordinate of the centroid of the element is y over 2. So Ixy equals integral from 0 to b of xy dA. The limits would be 0 to b because the variable of integration is x, so it ranges from 0 to b. Then x coordinate of the centroid of the element, which is just x. Y is y over 2 from the figure, the y coordinate of the centroid of the element. So Ixy equals integral from 0 to b of x y over 2 differential area y dx from the figure. So Ixy equals 1/2 integral of x y square from 0 to b dx, where y square is the square of this equation, so it is h square x to the fourth over b to the fourth. So Ixy is 1/2 integral 0 to b of x times quantity h square x to the fourth over b to the fourth dx. Simplifying, Ixy equals h square over 2b to the fourth, then integral of x to the 5 dx from 0 to b. So Ixy equals h square over 2b to the fourth, quantity x to the 6 over 6 from 0 to b. So product of inertia with respect to xy axis is h square over 12 b to the fourth, quantity b to the 6 minus 0. So therefore Ixy equals b square h square over 12. For the centroidal product of inertia of this area, so you need to know the location of the centroid of this parabolic segment, which is complementary parabola. Now, if you cannot recall the location of the centroid, then you have to review it from distributed forces, centroids of masses, also in this playlist. And you can find the derivation there. And if you can derive, then derive it again. The area is 1/3 base times height. You can easily verify that. It's only the centroid applying the first moment of mass concept. So for the x coordinate of the centroid, this is the tangent line and this is the vertex along the tangent line to the centroid, 3/4 of b. So barred x is 3/4 of b, while barred y is 3/10 of h. So that's 3/10 of h. So substitute into the formula ixy equals I barred xy plus area barred x barred y. So b square h square over 12 equals I barred xy plus area of spandrel 1/3 of base times height. Barred x is 3/4 of b and barred y is 3/10 of h. So simplifying, b square h square over 12 equals centroidal product of inertia I barred xy plus 3 over 40 b square h square. So these are like terms. 112 minus 3 over 40, we can now find I barred xy, which is equal to b square h square over 120. So that's it for this problem. Level 119, determined by direct integration the product of inertia of the given area with respect to the x and y axis. So here is the given figure. Let's select again vertical strip for our solution. The height is y, and take note it lies in the fourth quadrant. So the coordinate y is negative, but for the differential area part, let's treat it positive. The thickness is dx, the distance of the strip from the y-axis is x, and therefore its y coordinate is y over 2. So in the formula, ixy equals integral of xy dA, then dA is y dx, while y is, in this case, y over 2. And it is supposedly negative because it is below the x-axis. The expected product of inertia is negative because the area lies in the fourth quadrant where x is positive and y is negative. But the area is always positive, so that's why we anticipate that the sign of the product of inertia with respect to xy axis of this region is negative. So again, y is y over 2. So ixy is integral from a to 2a because the variable of integration is x. So it begins with a and ends with 2a. So we have x, which is just x, integral of x, which is just x, y, which is y over 2, and dy dx. So ixy therefore is integral from a to 1/2 integral from a to 2a of x times y dx. So I break down y square into y and y because this y dx should be treated positive and this y here should be treated negative. So y equals k over x, which is given in this figure when y is negative a, x is positive a. So this is a comma negative a. So negative a equals k over a. Therefore, k is negative a square. So substitute the value of y into this. Ixy equals 1/2 integral from a to 2a of x, quantity negative a square over x, that's y, k over x. Then the other y is a square over x dx because it should be treated positive. X is positive. Then we have ixy equals negative a to the fourth over 2 integral of dx over x. The integral of dx over x is ln, so therefore ixy equals negative a to the fourth over 2 quantity ln of x from a to 2a. Substitute ixy equals negative a to the fourth over 2 quantity ln of 2a minus ln of a. Since ln of 2a minus ln of a is ln of quantity 2a over a, so ixy equals negative a to the fourth over 2 quantity ln of 2a over a. Cancel out a, so this ixy is negative a to the fourth ln of 2 over 2. And approximately it is equal to negative 0.3466 a to the fourth.